This is my 95 Chevy. So I'm trying to fix the fact that my blower fan doesn't work on speeds 1 through 3, and that it does work on 4, but the blower motor has failed. It's extremely noisy when it does work on 4. The bearings have failed in the motor. First thing to do is to remove the glove box door, which you can see I've done here. And this little plastic cable is what holds the glove box from falling down. So that's what you have to remove first. And then you just fold the left and the right sides of the glove box in, and you can remove the glove box door. I'm going to go after the final stage resistor, which is in here. So once you get the glove box out of the way, this is the view that you see. You have to remove those 2 screws that are on the left and the right of that black relay. You can tell that bracket. And that's going to give you the access to the blower resistor that's back behind there. To get to this point, you have to remove this resistor right here. And those 2 screws are 9/32. Really, they're 8 millimeters. So I have this pocket screwdriver wedged in there to remove that clip. So I'm going to remove that clip, which is for the electrical connector, pop that off, and then take the screws out. So that screw right there has to be removed with an 8 millimeter wrench. Next, you have to remove the connectors for the computer that lives directly above the heater, so that way you can try to get that screw right back there out. After you get the shield off, you have access to the heater fan. The old ground screw on the right hand motor needs to be transferred over here, so don't forget that. So the computer clips were a little bit hard to work with when it's up in there. So here's how I removed them. I had a pocket screwdriver, I went down, and just like this is sitting on the floor, up in the dashboard, it's sitting on a piece of plastic trim. So you put the screwdriver in and you pry down, and you're going to, when this is not moving, you're going to be able to pry these clips out of the computer. So these, you have to pry these out to be able to remove this computer to do the job. So here's the tools that I use to do this job. 1/4-inch ratchet, I think that's a 6-inch 1/4-inch extension, deep 9/32, 1/4-inch drive socket, short 9/32, 1/4-inch socket, U-joint, 1/4-inch drive, and that's blurry, but that's a 7mm wrench. So I believe the nuts in the, I'm sorry, they're actually small sheet metal screws, but the bolts are 7mm, but here at home I didn't have any of that exact size and sockets, so 9/32 got me by. And if you want to diagnose whether or not your final stage resistor, the blower fan resistor, is good, you're going to want a meter. And here is the old blower fan motor, and you can see that it's got a date on it from 1994, and that truck is a 95, and I have 232,000 miles on it. So to me, that's asking a lot, and that's pretty good to have a blower motor go that long in both time and mileage. And I can tell you that when I went to AutoZone, they had a VDO. They gave me two options on a new replacement. Both of them were the exact same price, same warranty. One was VDO, and I forget the other brand. I think it was like Everlast or Ever something, but whatever it was, they were same price, same warranty. I chose the VDO only because I've heard of their name before. I've seen them used in OEM gauges and things like that, and I guess I heard of that name, and I never have heard of the other name used in OEM parts before. I could be wrong, but with that being said, the VDO fan that I put in, I can tell right off the bat that it doesn't spin as fast. It doesn't seem to put out as much airflow, as much CFM, or it just feels a little bit weaker. But it is quiet, and I'm happy. The old one here, if I spin it, I can't. This camera I have is so big, I can't put it down. But if I sit here and spin the squirrel cage, the bearing squeaks. So that's how I knew it was time. Some guys on the internet said that you can get by with just spraying some oil into the bearing, but this thing sounded like it was crunching up plastic, and it just sounded terrible. So with this kind of mileage, I didn't mind putting $25 into having this fan work for me. And I think that I call it a final, where I work at, they call them a final stage blower resistor. But the blower resistor at AutoZone is also like, I think it's like around $21. It's something like that. So if everything failed on your blower fan system, meaning this here fan and the resistor, you're looking at around $45, $50 with tax to get you back going again. And where I used to live, having this thing not work was not a big deal in Southern California. You could get by, pretty much most of the year without worrying if your heater worked or the air conditioner. I moved cross country, and they have 4 seasons, and basically this can make you late to work, and this can make you have an accident if you can't see out your windshield. So it's kind of not an option for me. So hopefully this helps somebody out there. I know there's other videos out there like it, but hopefully some of the pictures and stuff will help you, and some of the tools. Alright, thanks a lot. Alright, so here's the blower resistor. There's a couple resistors in here, and when you check these, every terminal should have resistance to the other. Like there's 4 terminals, they all 4 should have resistance to each other. None of them should be open circuit or OL. So I have my alligator probe on 1. I'm just gonna check them. So look at my meter. So that has 2 ohms of resistance. The next one has 1.8. The third one is nothing. If I move my clip to the third one, and then I check all the other 3. Nothing, OL, OL, OL. So, bad resistor. Which, actually this is a bad resistor because you can see the resistor there in the middle. The thing that looks like a little sinker. That's the problem. Alright, I know this is a bad video, but this is the electrical connector to the final stage blower resistor. And I have one of my alligator clips to the ground, a good ground on the dashboard frame. And I just picked the very top wire here. And I have my switch, which you're not going to be able to see, on the first position. So it says 0 volts. So I'm going to change the switch to the next position. 0 volts. I'm going to change it to the next position. 0 volts. And so I was off, and then it was 1, and then it was 2. Here comes position 3. So in the third position, I got 12 volts. So I know that if I have 12 volts coming into this connector, I don't have a power supply problem to the final stage. So I'm going to go the next connector down, and so now the second connector terminal has 0 volts. That's actually reading tenths. So I'm going to go to position 2. And we see position 2 has 12 volts from the switch. So I'm going to move this to the next one. Back to, that's basically millivolts, so it's 0 volts there. And I'm going to go to connector, or terminal 1, switch position 1. I got nothing. That was that third one. So then let me move this to the very last terminal. And we see we have 12 volts. So in all 3 of the first positions from the switch, this connector is getting voltage. So just one more piece of the proof of the pudding that the blower resistor is bad.